Hello all, and I thank all the viewers and as well as subscribers of the channel for the past two videos on my channel on the titles mesh and nodal analysis. And for today's session we are going to see about under the DC circuit analysis we are going to see about the super mesh analysis. As we all know that there are two laws, one is your Kirchoffs voltage law and Kirchoffs current law, that is commonly categorized as Kirchoffs laws. And for this Kirchoffs current law and voltage law, the main law that is used is your Ohm's law. We know that the Ohm's law is V is equal to your I into R, that is your current is directly proportional to V. So your current is equal to constant K into V, where K is called as a proportionality constant, where I is equal to your G into V, where G is called as a conductance, and G is equal to your 1 by R. So your I that is equal to V by R. So when we see into the analysis, super mesh analysis, what is it? We can see as, so for example, in a circuit, if we have an voltage source, then we say that we may use mesh analysis to find the loop currents. But whereas in a circuit, if we have current source, then we go for nodal analysis to find the node voltages, and by using the node voltages we can able to find the current through each element. So if there are two special cases, one is if in a circuit we have both voltage and current source, and the second case is also the same, we have both voltage source and current source. Both cases are one and the same, in which the circuits will be having both voltage and current sources. But whereas here the first case is in a circuit which is having an voltage source and as well as a current source, where the current source is in between two loops, then we go for super mesh analysis. And in the second case you are having voltage and current source. So see here current source is the major source, and if we have an voltage source in between two nodes, then we go for the super node analysis. The positive and negative critics of using super mesh analysis and super node analysis can be better learned by taking into a problem. Now this is the circuit that has been given to find the loop currents. The question is find the three mesh currents using these loops. So see here we are having an voltage source and as well as we are having a current source. So now you have to see the position of the current source and voltage source. The voltage source is at the end, but whereas the current source is placed in between two loops. When a current source is in between two loops, then the analysis that we have to choose is the super mesh analysis. Now what we want to do is, we know that how many loops we have? We have three loops. First name the loops as 1, 2 and 3. Now we have to give the direction of the current flow for all the three loops. For the loop number 1, let the direction, since we are having a source, the current is flowing from the positive to negative. Term the current as I1. And for the loop number 2, you don't have any source, so always start the current direction from a node, so which is called as your I2. For the loop number 3, you have a current source, but it is a mandatory condition that you should not take the direction of the current in any loop. So since the voltage source is not present here, what we can do is we have to start the current from a node. So your I1, I2 and I3. Now see here how we can reduce this circuit is, so by super mesh analysis, first what we want to do is we have to lift out this current source. How we can lift out this current source is, see, the I1 current is in same direction as that of your source, current source, but whereas the I3 current is in opposite direction to that of this current source. Now how we can lift out this 7 amps current source is, so I1 is in same direction, so plus I1, and your I3 is in opposite direction, so minus I3. So this should be equal to your 7 amps. So this equation is called as your equation number 1, and this equation is called as your super mesh equation. Now this loop could be redrawn as, so you are having an voltage source which is your positive and negative 7 volts, and next one is we are having the 1 ohm resistor, and next one is we have one another resistor which is 2 ohms. Between these two resistors we are having the 3 ohm resistor. Now this current source has been lifted out, that means that has been swapped out by using this super mesh equation. Now this will be open circuited. If an open circuit, and as well as you are having an resistance of 2 ohms, now in the open circuit the resistance offered by the open circuit is infinity. Infinity plus 2 is again an infinity, so no current will flow through this infinite path. So we can take off this complete plinth of a single layer, and then we are having this 1 ohm resistor. Now what we can do is, let the direction of your I1, I2 and I3 be the same. I1, I2, I3 be the same. So but whereas what we want to do next is we have to write the equation, okay, mesh equations by using your super mesh analysis. How we can write the equation is, so we can write it as, so this is your loop number 1 and this is your loop number 3. Now between that there was a path, okay, which has been lifted off. So now the two loops can be combined. So how it could be combined is, so we have to take the direction between that. So how we can take the direction is, put dotted lines between your I1 and I3. So this I1 current is called as a major current. So this I1 will be flowing like this, which is shown in the red color. So now this is the direction. Now what we can do is, we have to use Kirchoffs voltage law to frame the equations in this super loop and as well as in this loop. First let me write the mesh equation at the loop number 2. Mesh equation at loop number 2. So the mesh equation at loop number 2, by using your Kirchoffs voltage law, your Kirchoffs voltage law states that in a closed loop the potential rise is equal to the potential drop. The potential rise is equal to the potential drop. So in this loop you don't have any source, so the potential rise is equal to 0. But whereas the potential drop will occur across 1, 2 and 3. So your 1 into, what is the current that is flowing through this one? Your I2 and as well as I1. Now as far as this loop is concerned about, your I2 is a major current. So your I2, okay, is flowing in upward direction, but whereas your I1 in opposite direction. So you can write as I2 minus your I1 plus 2 times your I2 is the only current which is flowing through this 2 ohms. So 2 into your I2 plus 3 into your, for the 3 ohm resistor, your I2 is flowing like this direction, but whereas your I3 is flowing in this direction. So both are in opposite direction. So now the major current is your I2. So I2 minus your I3. So we can write it as I2 minus I1 plus 2 times I2 plus 3 times I2 minus 3 times I3, which is equal to 0. So 0 is equal to minus I1. So 2 times I2 plus 3 times I2, which is 5 times I2. 5 times I2 plus 1 time I2 is called as your 6 times I2, and your I3 value is minus 3 times I3. Now this equation is called as the second equation. Now what we want to do at the next step is, we have to use Kirchoffs voltage law at the super loop. We have to use the Kirchoffs voltage law at the super loop. How we can use is, so here also the potential rise is equal to the potential drop. For this super loop, the potential rise is 7 volts. So 7 is equal to the same. What is the resistance here? 1. Okay. The 1 is in between your first and second loop. So we can write it as 1 is flowing downward, whereas your I2 in opposite direction. So your I1 minus your I2. And whereas your 3 into your I3 is floating in this direction from left to right, but whereas your I2 is flowing from your right to left. So this is called as your I3 minus your I2. And another one resistor is plus 1 into, only I3 is flowing in this direction, so plus 1 times I3. So 7 is equal to I1, 1 into I1 minus I2 plus 3 into I3 minus I2 plus 1 into your I3. The foremost point that you have to concentrate here is, here in this super loop, your I1 is a major current. Why the I1 direction is taken here in this third loop is, here the direction of the I1 is taken as a prime implicant, and wheresoever your I3 is non-coherent with your I1 direction, you have to mark minus in front of your I3. For example, if your I3 is opposite direction, I3 is in opposite direction, so what you should do here is, here instead of writing 3 times I3 minus I2, you have to write it as 3 times minus I3 minus I2, because since your I3 is in same direction as that of I1, you are putting it as plus I3 minus I2. If both I3 and as plus I2 both are in opposite direction to that of your I1, you want to emboss a minus sign in front of this I3. Now this equation could be solved as, we can write it as, which is your I1 minus I2 plus 3 times I3 minus 3 times I2 plus 1 times I3, which is equal to your I1, and your I2 is minus 1 I2 minus 3 I2 minus 4 times I2. 3 I3 plus 1 I3 is called as your 4 times I3, which is your 7. So this is your third equation. So your first equation is I1 minus I3 is equal to 7, and second equation is this, and third equation is this. This equation can be written as 1 I1 plus 0 I2 minus 1 times I3, which is equal to 7. Then by using your normal calculator option, what we have to do, always whenever we start anything with the calculator, click shift and mode, reset all the elements, and now what you have to do is click mode thrice, you will get equations. So 1, and how many unknowns we have? I1, I2 and I3, 3 unknowns. So your unknowns is 3. Now what we want to do is, you want to write your A1, B1 and C1 and D1. So your A1 is 1, and your B1 is your 0, and your C1 is your minus 1, and your D1 is your 7, and your A2 is your minus 1, and B2 is your 6, and C2 is your minus 3, which is equal to your 0. So minus 1 and your 6 and your minus 3, and your D2 is your 0, and your A3, B3 and C3, what you want to do is A3, B3 and C3, which is equal to your D3. So your 1 is equal to your minus 4, equal to your 4, equal to your 7. So what you have written, your A1 is this value, B1 is this value, and C1 is this value, and D1 is your 7, and your A2 is your minus 1, and B2 is your 6, and C2 is your minus 3, and your D2 is your 0, and your A3 value is your 1, and your B3 value is your minus 4, and C3 value is your 4, and your D3 value is again 7. So what you can want to do is, now the values are, the value of your I1 is 9, the value of your I2 is your 2.5, and the value of your I3 is, which is 2. So you have got the 3 loop equations, 3 mesh currents, by using the super mesh analysis. Again, for instance, let me disguise this. So what we are doing is, we are finding the mesh currents by using your super mesh analysis. When super mesh analysis is applicable is when we are having a current source in between two loops, then we go for the super mesh analysis. Here we are having a current source of 7 amps between your first loop and third loop. Now we are optimizing the equation as since I1 is in same direction as that of the 7 amps, so plus I1, I3 is in opposite direction, so minus I3 is equal to 7. Now what we want to do is we have to lift off this 7 amps. So how we can lift off is when we lift off, this is an open, okay, the equivalent for the current source is your open circuit. The open circuit will be having infinite resistance. Infinite resistance plus 2 is called as your again infinite, so no current will flow through this, so we can simply wipe off the complete limb, and then your I1, I2 and I3 completely exist. But whereas your I1 is a major direction, your I1 current is having the major direction, so you give the direction of your I1 in the third loop also. Now find the mesh equation by using KVL for the loop number 2, and as well as find the mesh equation by using your KVL for the super loop also. So you got the values of your I1, I2 and I3 as 9, 2.5 and 2, and thank you all.